Hi everyone, this is the first in a series of homework help videos for the linear programming problems. In this video I thought I would just give you a few general hints for all of these problems before I go into the specific problems themselves. Okay, so the first general hint is determining if a graph is going to be bounded versus unbounded. So there are, I believe, maybe just one unbounded problem in this section. But in general, if you can see that there is no constraint which kind of puts an upper restriction on a graph, then it's going to be something that's unbounded. So for example, if you have, we did one with the vitamin requirements, vitamin pills, or if you have something like, if all of your constraints happen to be greater than or equal to a number, then that means that you're going to be, when you graph, shading above lines that are like that, but if there is no limit on the x or the y, something like x is less than 3, then this will probably be a candidate for an unbounded graph. You might want to look at, let me find which one it is. Let's see, I think number 30 is an unbounded graph, number 30. Okay, so you might want to expect that. And then just a comment about finding the intersections of lines. So sometimes we talked about when you graph these, you end up with maybe a linear inequality here and maybe one here, and maybe you need one of these vertices for your your feasible region, and let's say you can't really tell what that is from the graph, right? So we talked about at least in section A, we talked about two methods to find solutions or intersection points for lines. So let me remind you of those. You can use substitution or elimination. Okay, so quick review. If I had something like 2x plus y equals 12, and then I needed the intersection with x equals 3, then substitution method would, if you know the value of one of your variables, so if you have like an x equals or a y equals, we can substitute that value into the first equation for that variable, and then solve for the other variable. Alright, so in this case I've substituted in 3, and then I can find that y equals 6. So that would tell me that the intersection of these two lines would be the point 3, 6. Alright, elimination, something like maybe it's 2x plus 3y equals 10, and let's see, how about 3x plus 4y equals 2. Okay, so then the goal of elimination is to add these equations in such a way that one of the variables, either x or y, cancels out. So in order to do that, we would need to have the x's have the same coefficients but opposite signs. Alright, so if I multiply this first equation by 3 and this second equation by -2, then that will happen. Okay, so the first equation would become 6x plus 9y equals 30, so I'm distributing the 3. And then the second equation becomes -6x minus 8y is -4. And then adding 6x minus 6x eliminates or cancels. And then 9y minus 8y is y. 30 minus 4 is 26. Okay, so now I know the value of y, and then I can substitute that back into either of the original equations to solve for x. Right, so I would have 3x plus 4 times 26 equals 2, and then you could go from there and solve for x. And then again, that point would also be the intersection of those two lines. If you need more help on this, you can just Google these terms, substitution, elimination. You can look for solving systems of equations, and then you should be able to find quite a bit of information online about how to do that. Alright, just a couple general hints there, and I will make a video for the rest of the problems to get you started on those.